For this lesson, we're going to be looking at word problems or applications of trigonometry. Um, Other than the fact that you have to read these questions carefully and try to understand how you're going to use trigonometry to solve these, once you actually get to the point where you have triangles, they're the same as any other question that you've done. So it is really important. Read the questions a couple of times, draw a diagram if at all possible, and then construct a triangle or multiple triangles that will allow you to answer the question that's being asked. And it's really important as you're doing your reading. Don't just focus on the question that's being asked, but of course you do need to know that piece of information. So in this case, we have two observers on the ground and they are standing 5 kilometers apart. And at the exact same moment in time, they see a small airplane flying above and directly between them. So there's the ground. I have my two observers, and they are 5 kilometers apart. And at the exact same moment in time, these two observers see a plane. Let's see, how am I going to draw this? And it is directly between them. So one observer looks up at the plane. So first of all, the plane is above the ground, so it's at some point directly above the ground at a right angle. One of the observers looks up and sees the plane at an angle of inclination of 51 degrees. And the other observer looks up and sees the plane above them at an angle of 40.5 degrees. And that's it. So now we're trying to find what is this altitude, what is this height h. And so if I were to do this, I would probably redraw this using two triangles. Now, we don't know that the plane is halfway between them. We only know that the plane is above this line that connects them. And we've done an example like this before in a previous lesson. If I call this x, then that means that this side must be 5 minus x. So this triangle will be x, this will be my height, this will be 51 degrees. And then the other triangle, it's another right angle triangle. Here's my height. This one is 40.5 degrees, and this is 5 minus x, which is the length of this side. So now let's go ahead and label these triangles. For this triangle, my angle of interest is 51 degrees. So there is the hypotenuse. This is the opposite side. This is the adjacent side. So I'll work with this red notation first. I'm interested in h and x. That's the opposite and the adjacent. So that's going to give me tan. So the tan of 51 degrees is equal to h divided by x. And where's that coming from? That's from SOHCAHTOA. Opposite and adjacent gives me tangent. And so now I'm going to cross multiply. I'm going to rewrite this as h is equal to x tan 51 degrees. And I'm just going to leave that for the time being because I have two variables here. I can't do anything, so I'm going to need another equation. So I'm going to get that other equation from here. My angle of interest is 40.5 degrees. Here's the hypotenuse across from the right angle. This is the opposite side, and this is the adjacent side. So with this one, again, I have opposite and adjacent, same as before, tangent. So we're actually going to say that the tangent of 40.5 degrees is equal to opposite divided by adjacent. That's h over 5 minus x. Oh, I didn't mean to go there. I meant to extend that page. Now I'm going to cross multiply. For this one, I end up with h equal to 5 minus x, but be careful here. This is the entire denominator. This is the entire denominator multiplied by the tan of 40.5 degrees. So we have to keep that bracket intact. So if we call that equation 1, call that equation 2, you should notice that h is equal to h. So that means that essentially what I'm saying is equation 1 is the same as equation 2. And so that means I can now write that x tan 51 degrees is equal to 5 minus x tan of 40.5 degrees. And how you approach this is up to you. You might choose to change this into a number and change this into a number. I prefer to leave that until the end, so I'm actually going to keep working algebraically here. So I have x tan 51 degrees. 5 times this, as I expand the bracket, that becomes 5 tan 40.5 degrees. Negative x times tan of 40.5 degrees. I'm going to bring all of my x's to one side, so I'm going to bring this term over to the left side. So I end up with x tan 51 degrees plus x tan 40.5 degrees is equal to 5 tan 40.5 degrees. This is just a number. I've got variables here. I factor out the x because I want the x just by itself. And so I end up with tan 51 degrees plus tan 40.5 degrees equals 5 tan 40.5 degrees. Don't be intimidated by this. Remember, these are just numbers. The tan of 51 degrees, put that in your calculator, you get a number. Same for tan of 40.5. And now I'm going to take this whole thing, I'm going to divide both sides by that. So now I end up with x is equal to 5 tan of 40.5 degrees over tan 51 degrees plus tan of 40.5 degrees. Now I'm ready to give myself an answer. Be careful again. This is all in the denominator. So if your calculator skills allow it, then you can go ahead and do that all in one step. But otherwise, you might want to calculate that denominator first. So I think I'm going to trust that I can do this all in one. So that's 5 times tan of 40.5. And that's divided by, and I'm going to use the brackets on my calculator to help me do this, tan of 51 plus tan of 40.5, and that goes in the denominator. And so I ended up with, and I'm going to actually do this calculation a second time just to be on the safe side, I ended up with x is equal to approximately 2.0443. So I'm just going to check that, and I'm going to do this another way. So now I'm actually going to calculate the denominator separately. So when I calculated the denominator separately, I ended up with 2.0888, actually 2.0890 rounded. And then I'm going to take that number and I'm going to go 5 times the tangent of 40.5 divided by the answer I just got there. And yep, so I verified that that's correct. And then I'm going to go back here because I need to solve for h. So I'm going to take this value, h equals x tan 51 degrees. And that's x tan 51 degrees, and so h is approximately equal to, notice I'm not even going to write this here, I'm using this value that's still in my calculator, I'm going to multiply that by the tan of 51 degrees, and I end up with 2.5244. Therefore, the altitude of the plane is 2.5 kilometers. Okay. Next question, we have, in this case, landscaping, which is a fairly common use for triangles, for surveying. Her job is to measure properties for a triangular piece of land. Two sides measure 4.9 meters and 5.8 meters, and they meet at a common point separated by a 35-degree angle. So I'm going to draw something like that. 4.9 meters and 5.8 meters, and they meet at a common 35-degree angle. I probably made this side a little too long, but that's okay. And so there is the third side of my triangle. Here's the information that I'm given. We want to find the total perimeter and the area of the piece of land. So it's not a terrible idea to label this. So I'm just going to label this A, B, C. I want to know the length of this side, and that is the side B because it's across from the angle B. And I also, if I want the area, so perimeter is just adding up the sides. So for the perimeter, I just need to know what is B, and then I can add up the three sides. For the area, I need to know the height of the triangle. So I'm going to drop a vertical there. And so for area, I need the height of the triangle. And I can do these in either order, but I'm going to start off with the perimeter. Just going to move this all over a little bit more so I have some more room over here. So let's go ahead and start with the perimeter. Now to find this side B, I take a look and I have side angle side. So first of all, side angle side tells me I want to use the cosine law. And I'm trying to find the side B, and I have the angle B, so it looks like we're actually set up fairly well to make use of this as B squared equals A squared plus C squared minus 2AC cosine of the angle B. So B squared is equal to A squared, that would be 5.8 squared, plus 4.9 squared minus 2 times 5.8 times 4.9 times the cosine of the angle, which is 35 degrees. So B squared is equal to, actually no, I'm going to go straight to B here. So all in my calculator, I'm going to do 5.8 squared plus 4.9 squared minus 2 times 5.8 times 4.9 times the cosine of 35 degrees, and I want to make sure my calculator is in degree mode, and that is equal to approximately, you know what, I'll put it in here just in case you're following along, 11.0894. That's rounded to 4 decimal places, but I'm actually going to use my calculator again, and I'm just going to take the square root of the number I just got there, and I end up with 3.3301 rounded to 4 decimal places. Now, when I write my concluding statement, or when I figure out my answers, I'm going to probably round to 1 decimal place. So 4 decimal places here is plenty. Now I'm not going to use this number for calculating the area anyway. That's a separate calculation. So now I can finish that off and say, okay, perimeter is equal to 4.9 plus 5.8 plus, and I'm going to round to 1 decimal place, 3.3301, and that's approximate. And so I add in those other ones, 4.9 plus 5.8, and I end up with 14, and I'm just going to go ahead and round it to 1 decimal place at this point. So there's my perimeter. Now to find my area, I'm going to need to find this height. So I can probably do a little bit of work here. So to find that height, I've just got a little right angled triangle here. And so let's change colors. here's my angle of interest. This is a right angled triangle, so this would be the hypotenuse, this would be the opposite, and this would be the adjacent. And when I say I'm working between here, here, and here, that's the right angle triangle that I'm working on. So for this one, I'm interested in opposite and I have hypotenuse, and so I'm going to use SOHCAHTOA, where I'm interested in opposite and I have the hypotenuse and I have the angle, so I'm going to use sine. So I'm going to say the sine of 35 degrees is equal to h divided by 4.9. So h is equal to 4.9 sine 35 degrees. And from there, I'm not going to resolve that into a number. I'm actually going to now make use of the fact that area is equal to 1/2 base times height, which is 1/2. What is the base of this whole triangle? It's 5.8 the way I've drawn it. And the height is 4.9 sine 35 degrees. And as you can see, once again, I've set myself up so that I can do this all in one step on my calculator. 1/2 times 5.8 times 4.9 times the sine of 35 degrees is equal to approximately 8 and I'm just going to go ahead and round this to one decimal place. That's the area. It's approximately 8.2, but I should put in a therefore statement so I can include my units. So therefore, perimeter is 14.0, and what are our units? Meters. And the area is 8.2, and that will be square meters. Okay, now on to what may be some new concepts for some people. There are some word problems in your assigned work. They do come up that deal with directions and bearings. So when we talk about a direction, a compass direction, so we have north, south, east, and west, and it's always, first of all, these are always right angles between north and east and south. Those are all right angles. And then when we talk about these measurements, we always refer to the closest in between here. So for example, if I'm somewhere up here between north and east, I'm not going to include the letters S or W. I always try to make directions, and directions will always be given to you in terms of the closest compass directions. Now there's another type of measurement, and this is more traditionally used in navigation, whether it's on air or whether it's on sea. So planes might use this and ships might use this, and it's known as a bearing. Now a bearing is always measured from north, and when we talk about the bearing, then that is an angle that is measured starting at north. You go clockwise, and it can be any number between 0 and 360. Once you've gotten to 360, you come all the way back around again. So that's another way. And for those of you who are a little bit more interested in this, there's actually the more traditional way of measuring a bearing actually has to do with the direction that the ship or the plane is traveling, but that's more complicated for us. So we're going to always use just with respect to north. So here are a few examples. So let's say you have the compass direction north 10 degrees east. That means you start facing north and then you turn 10 degrees to the east. East is over here. So I start facing north and I turn 10 degrees to the east. That is the same as a bearing 010, which means you start north and you turn clockwise by 10 degrees. North 40 degrees west. We start facing north and we turn 40 degrees in the west direction. So that's down this way. So there's your 40 degrees west. Or a bearing of 320, start going north and then start turning clockwise until you get to 320. Well, that would be 90 plus another 90 is 180 plus another 90 is 270, and then whatever's left over. So that would be 320 going that direction. Southwest, there's no number in between these, and so that means that the number in between is 0. It means southwest, actually 0 is probably not the right way of describing that. The number in between is actually 45. So let me try that again. So that really means south 45 degrees west. We start at south, which is here, and we turn towards the west 45 degrees. So when you see it southwest, two letters next to each other, it means that it's halfway in between each of those. Or a bearing of 225, start at north and then start going clockwise. 90 plus another 90 is 180, plus another 45 is 225. This comes very easily to some people. This is quite difficult for others. So you're going to have to just be careful and figure out where you lie with respect to that. Okay, so there we go. We've got some assigned work. A couple of these are quite simple, and you've got references here to the matching example from the textbook, and then some other questions in general. We've got our test coming up, so those are the review questions that go along with it.